So, a sampling distribution without replacement is a distribution of a sample where each item can only be selected once. This is different from sampling with replacement, where items can be selected more than once. How does sampling without replacement work? Each item in the population can only be selected once. The probability of selecting an item depends on which items have already been selected. The selection of an item is not independent because it depends on the previous selection. The probabilities of the elements being chosen do not change throughout the sampling process. Why is sampling without replacement important? It's essential in making valid inferences about the population from the sample statistics. It's the default assumption for statistical sampling. Let's now proceed on problem solving.
The population mean, use this formula. Mean is equals to sum of all courses over the number of individuals. Mean is equals to 7 plus 9 plus 2 plus 6 plus 3 plus 14 over 6. The mean is 6.83 months. To get the population variance, use this formula. Sigma squared is equals to sum of the quantity of x minus mean raised to 2 over the number of individuals. So, sigma squared is equals to 94.8534 over 6. Sigma squared is equals to 15.8089 or sigma squared is equals to 15.81. To get the population standard deviation, use this formula. Sigma is equals to square root of sigma squared. Sigma is equals to 15.8089. The sigma is 3.9760 or sigma is equals to 3.98.
Now for the letter B, now since n is equal to 6 and r is equal to 2, we just need to put it in a calculator in the format of 6 combination of 2 equals 15. Now for the table, since we got 15, that's how many we are going to put in the observation. For the next column, we just need to put in the names of the crush. But since we use the combination, there are no repeating names. And to get the nonce, we just need to get it from the given. For the sample mean, we just need to add the months and divide it by 2. For example, observation 1, we have Eloise and Charlotte. Their months are 7 and 9. We just add and divide it by 2 and do the same for the rest and total it, so our answer should be 102.5. For the next column, we just need to minus the sample mean to the mean of the population mean, which the answer is 1.17. For the last column, we just need to square the sample mean minus the mean of the population mean, and the answer is 1.3689. Now you just need to do it to the rest of the observation, and if you did it correctly, the total of the last column should be 94.8335.
After gathering all the data that we need, we can now proceed to the step 3 or sampling distribution. First, we're getting the mean. For our mean, we have the sampling distribution mean is equals to the summation of sample mean over NCR. We're just going to plug in the data that we gathered here earlier. So 102.5 over 15 is equals to 6.83 months. Now we have the variance. Our variance, we have the variance squared over sample mean is equals to the summation of sample mean minus the mean sample mean squared over NCR. We're just going to plug in the values earlier. We have 8,335 over 15. After that, we're getting the 6.3 6.3222, and we're getting the second decimal point is 6.32. Next, we have the standard deviation. We have the variance of sample mean. We're just going to get the square root of the variance squared sample mean. So 6.3222 is equals to 2.5144, and we're going to get the second decimal placement. We have the 2.51 months. That's it.
Now, we calculate the probability of selecting an even number from the dataset. 1/15 plus 1/15 plus 2/15 plus 1/15 equal 5/15 or 0.33 or 33.33%. This means that there is a 33.33% chance that it will be an even number. Now, we calculate the probability of selecting an odd number. Probability of 5 equal 1/15 or 0.67 or 6.67. This tells us that the probability of selecting 5 is 6.67%. Lastly, we find the probability of selecting a value that is at most 5. 1/15 plus 1/15 plus 2/15 plus 1/15 equal 5/15 equal 1/3 or 0.33 or 33.33%. There is a 33.33% chance of selecting a value that is at most 5.